we're going to work on section 7.2, which is solving linear systems by substitution. And I have up there, get out a different color pen or pencil, because it might help you in being able to do some writing along the way. We're going to be writing a bunch of equations, and you need to be able to determine which equation goes where on the way. Solving linear systems by substitution. To substitute means to put one thing in for another, something that is equal to another. And with substitution, one of the things that's going to be important is that we have written one of the equations so that it's y equals or x equals. So you have to be able to write one of the equations as y equals or as x equals. If the author already has it as a y equals for you, use that hint and go ahead and keep it as y equals. Don't change it to an x equals. One of the equations has to be written as a y equals or an x equals. And here's where my different color pen comes into account. This is a system, y equals 2x minus 3 and x plus 3y equals 5. We're not going to graph today.
Yeah.
All right. But instead, we're going to use what's called substitution. And this is going to be the second thing I'm going to assess on our quiz that we're going to have. I'm going to assess whether you can solve by graphing, and I'm going to assess whether you can solve by substitution. Y is equal to 2x minus 3. And what we're going to do is we're going to substitute that in for y in the other equation. Okay, we're going to substitute what y is equal to in for y in the other equation. That's why this is called the substitution method. So with my pen here, I'm going to write x plus 3 times what y is equal to. And y is equal to that 2x minus 3. This is where that colored pen or pencil comes in, so that you can see, oh, in for the y, I'm going to put what the first equation is in. Now, could these two equations be flipped around? Definitely. Okay, so it's not because it's the first equation. It's the other equation. Okay, Evan.
What if they were both y equals, it would still be the same thing?
Yeah, you just substitute one in for the y in the other equation.
Okay.
Okay? All right. So now I have an equation that has all what kind of variable in it? X's. And if I have an equation with all the same variables in them, I can solve for that variable. So let's go ahead and start doing our distributive property and combining of like terms along the way. Rachel, can you tell me what I might have when we do the distributive property here?
6x minus 9 equals 5.
All right, awesome. And then let's combine our like terms. Andrew, can you tell me what we're going to have when we combine like terms?
You're going to have 7x minus 9 equals 5.
All righty. Now we have a two-step equation. Hayden, what's the first thing we're going to do?
And then
So what do we get?
7x equals 14.
7x equals 14. All right. And last but not least, Spencer, what are we going to do?
Divide by 7 plus x equals 2.
And x equals 2. Okay. We have just found one of our two answers. X equals 2. What we are going to do with that answer now is we are going to substitute that x equals 2 back into one of the two equations. And I'm going to use a different color here. I'm going to use green. So we got x equals 2. And you can either put that in here or you can put it in here. Either one, you can substitute back in to either equation. It does not matter. But let me just comment to you. One equation works quicker than the other. Okay. If we substitute it into the top one, it's y equals 2 times what x is. So x is 2. What's 2 times 2, class?
4.
So I got y equals 4 minus 3. What's 4 minus 3, class?
5.
And now I have my other coordinate. So I'm going to write my answer as 2, comma, 1, and I can put a box around it. Now, as I commented with graphing, you should take that xy pair and make sure it works in both equations. Okay. We know that 2 times 2 is 4 minus 3 gives us 1. We know it works with this one. Let's check the other equation. If x is 1, if x is 2, my apologies, and y is 1, I've got 2 plus 3 times 1, 2 plus 3 is 5. It works in the second equation. I know that that is my correct answer. Now, we got a little bit of railroad tracks going on up there, a little bit of, arrows. Take a look at it, saying, okay, I substituted in here, I solved for my x, then I substitute it back into either one of these top equations, and that's what I did over here on the right, so that I could find out what y is. Once I've got my x and my y, I've got my xy pair. Grant?
When you start out with the two equations, if like one of them's not in y equals, then you have to change it there.
If they're both in standard form, you need to put one of them either in y equals or x equals, whatever works best for the problem. You can use an x equals also. Sometimes it doesn't work nice because there's a lot of fractions involved. But if it's, works out great, then go ahead and use it. Through practice, you'll start to go, oh, I can solve for x on this one, and it'll work really easy. Okay? Sometimes it'll be y equals, sometimes it'll be x equals.
So if you put it into the x equals, then would you do like the opposite of what we just did?
No, you're not doing the opposite. Then you would put, if I had this one solved for x up here, I would substitute it in for x in this equation rather than the y.
Yeah. And then,
Okay, and then what you come up with is the y, and then you have to substitute back in up here in order to find the x. Okay. Other questions so far? A little different, isn't it? This is called an algebraic way of solving a linear system. On your test, on your quiz, I will say solve by using substitution method. And I will expect to see this method because there is another algebraic method. It's called linear combination. I'll teach that another day. And sometimes what happens is students go, I like this method or I like this method, so I'm always going to use that one. I need to know that you know all three methods. You need to be able to do it graphically, and you need to do it algebraically, the two ways that I'm going to teach you. So when you're doing this on a test or a quiz, I'm going to be looking for a specific method, like substitution. And if you don't use this method, if instead you use the other algebraic method, I won't give you any points for your answer because you didn't show me that you could use the substitution method. If you do a graphing problem using the substitution method, I won't give you any points because you didn't graph it in order to come up with the answer. Does that make sense? Awesome. I caution you because I've had students do that, and then they get mad at me when they flunk a quiz. I said, well, you didn't show me that you could graph the problems. All you got was the substitution part. Then you got 50%. So, be careful. Jot down these problems, these two equations, please. X minus y equals 3, and x plus 2y equals negative 6. I think this is going along with what Grant was asking about before. You could solve for any x or y. I would caution you to always look for those variables that have a 1 as the leading coefficient to solve for. I would not solve for the 2y. I would not solve for the y that's with the 2 up here because that's going to cause me to have fractions. So I can either rewrite this top equation as x equals 3 plus y, and then substitute that in for x in this equation. Or what I can do is I can solve the bottom equation. Let's put the eraser in the right spot. I can put the bottom equation as negative 6 minus 2y, and then substitute that in for x in the top equation. It doesn't matter which one I solve for. I always substitute into the other equation. Anybody got a preference on which one we actually solve for? Which variable and which equation that we solve for? We got a preference? Adam?
Solve for x in the top.
Solve for x in the top equation is what Adam wants to do. All right. So let's make that x equals, and what's that going to be, Adam?
3 plus y.
3 plus y, or y plus 3, right? Doesn't matter. So I got x equals that. I am going to put what x is equal to in for x in the other equation. I'd like to know what that equation is going to look like now with the substitution in it. Kayla, can you tell me what that equation is going to look like with the substitution in it?
3 plus y.
3 plus y plus 2y equals negative 6. Exactly. Notice I put that 3 plus y in green so that you can see, oh, that's what was substituted into this equation. Now that I have all variables the same in the equation, now I can solve for that variable. Allie, what's this next line going to look like in starting to simplify this?
3 plus 3y equals negative 6.
All righty. What's the next line look like? Harrison?
3y equals
Pardon me?
3y equals negative.
Thank you, negative 9. Okay. And Cassidy, last equation here.
Y equals negative 3.
Okay. We now know what y is. In our xy pair, we know what y is. What do we have to find? X. How do we go about finding the x? Do you remember now what we need to do along the way? Jack, what do?
We go to the other equation and substitute negative 3 in for y.
You can do into either equation. It's okay. You can do either one, but it has to go in for the y, as you said. Okay. So where y is equal to negative 3, I can either put it in here, I can put it in here, or if you want, you could go into your equation that you rewrote. So it could go into any one of those places. Hint to you. I would probably go straight into this one. This is the one I would probably do because it's already x equals 3 plus what that negative 3 is there. Okay, what y is equal to negative 3. And so 3 plus negative 3 class is 0. So you find out, hey, x is 0. That's okay. You can have 0 for an answer. And so I find out that my xy pair is 0, negative 3. Well, let's check to make sure that works. 0 minus a negative 3. What does that equal to? Positive 3. 0 plus 2 times a negative 3. Well, what's 2 times a negative 3? Negative 6. It works in both equations. Okay? You can check your answer and make sure your answers work. You'll know on all of your problems for the quiz, 7-1 and 7-2, whether you have the right answers or not, because you can check your answers. You'll all know you got 100% when you turn in your quiz. Isn't that a nice idea? Questions here? Jake?
You're always plugging in. Like it kind of seems like you're plugging in the opposite variable.
Correct. You're plugging in for one variable, solving for the others. Okay? Because the deal is, Jake, if I have an equation with 2 different variables, can I find out what those 2 variables are? No. I can only have one variable in an equation. So I'm going to use what's called the substitution method. And if I know what y is equal to in terms of x, I can put it into the equation. Okay? Anybody else? I have another one here. Jot down the equation, and then let's talk about which variable we think we should solve for on this one. Negative 5x minus y equals 12, and 3x minus 5y equals 4. Do you have a thought about which one of the variables we should solve for? X or y in the first, or x or y in the second? Luke, what do you think?
Y in the second one, or the first one, excuse me.
Y in the first one?
Yeah.
Awesome idea. And you chose that because,
First one's the leading coefficient.
yeah, it actually is a negative 1 right now, but there's a 1 there, exactly. All the others have these lovely coefficients that if we start solving for them, you guys know you're going to end up with fractions in your equation. So I would not solve for the negative 5x. I would not solve for the 3x or the negative 5y. Okay, I want you to just talk to your partner. Would you please solve the top equation for y and substitute it into the other equation, and we'll start getting some people to work through this. So at this point, we have the y equals negative 12 minus 5x. Is this where you're starting to get a little confused as to where to put it back into? Yes, no? No? So we could go from here without a problem? Okay, talk to your neighbor, see what you can do. Go from here. As we look at the work that was done on the whiteboards and the smart board up here, we see that the substitution of what y was equal to, that substitution was right in here from this y. We had to put it in whatever variable you have solved for on that equation. That's the variable that you have to put in for in the other equation. As I was commenting to Andrew earlier, I said, if you put this equation back in the top one, you're going to get 0 equals 0. Everything's going to cancel out because you're substituting something back into itself. Okay. If I say that x equals 4, and thus x equals 4, okay, so I put 4 in for x, so I get 4 equals 4. That didn't help me do anything else. So that's why I always say put it in the other equation. I like how we have our distributive property up here. Everything's worked out. We find x is equal to 2. We've got an arrow going up saying here we're going to put x into this equation. And then the work comes right down from there on the right-hand side, and we find y equals a negative 2. And then here is our answer, negative 2 is our xy pair. Having our two sections here where we're looking for things, wonderful arrangement. It's very easy to see what's going on. I can see where you substituted in what you came up with. Then I can see where else you substituted and what you came up with for your other variable. I like how this is done up here. Okay. Questions here so far? Okay, getting a little easier? Okay, cool. Good, because you see I have another one up here. All right. Go to it. Feel free to talk to your partner on this. We have up here the substitution of negative 7 minus 3x. Notice that there was a 1 in front of this y. That was the best variable to solve for. Could it work with the other variables being solved for instead? Yes, it can, but you'll probably end up dealing with some fractions. And I know how much you guys love fractions. They are your best friends, your BFF, best friends fractions. BFFF, best friends fractions forever. All righty. So, in looking at this here, are there questions at this present time on this problem? We have work up here on the whiteboard as well, over here on the whiteboard. Everybody's got the correct answer, and the work is very good on those. Any questions? Are we feeling more confident about this? Doing better? That's time for a story problem? Yeah. Let's go there. All right. Many businesses pay website hosting companies to store and maintain computer files that make up their websites. Internet service providers also offer website hosting. The cost for website hosting offered by a website hosting company and an internet service provider are shown down below. It says find the number of months after which the total cost for a website hosting will be the same for both companies. Oh, Mrs. Deegan, you didn't give us an equation. Oh, no. But I bet you guys could come up with one for each of these. Could you come up with an equation that will give me the total cost for the internet service provider and an equation that will give me the total cost for the website hosting company? Talk to your partner and come up with those equations right now. So if we're talking about the variables, cost per month, that would be, cost would be your Y, because it's always change in Y over change in X.
Okay.
Remember that? Cost per month. So that tells you what your Y and your X are in terms of the variables. Okay, I'll let you continue talking. Okay, in looking at all the equations that we have up, everybody who came up to the board wrote the same equations. Awesome, you all got the right equations. Wonderful. We have $10 plus $21.95 for every month. And the other one, there is no setup fee. It's just $22.45 every month. Y here is our total cost, right? Now we're going to do substitution in order to solve this. We have to put one of the equations in either Y equals or X equals format. They're both in Y equals format. So therefore, what I can do is I can take what Y equals in one equation and put it in for Y in the other equation. So I'll have 10 plus 21.95x equals my 22.45x. Now, one of the questions up here was, find the number of months in which the total cost will be the same for both companies. Didn't we just set the costs equal to each other? Y equals Y. This cost for this company equals this cost for this company. Oh, they have all the same x's in. Great. Solve for x, will you please?
So anytime you have two y's and two x equals
You can put them right equal to each other because you're substituting one in for the other. Isn't that cool?
Yeah.
All right, finish up solving. I'll pause so that you guys can finish. All right, we have our 10 equals. What's the right-hand side going to look like when we take that 21.95x to the other side, Jack?
It's 20, just 0.5x.
0.5x. Okay, and then we have to divide by 0.5 on both sides, and what are we going to come up with, Allie? 20. So we have 20 what?
Months.
Months. So we are going to put the word months on here. And in 20 months, their two costs will be the same. We don't care what that cost is. They didn't ask us to find it. But if I had made you find it, what would you do with the 20? Adam?
You put the 20 in for x in one of the equations.
In one of the equations. It doesn't matter which one, and you could find out what that cost is. But they didn't ask us to find it. So I'm done. Any questions there? One more story problem. I thought today was a two-story problem day. Kirigami is the Japanese art of making paper designs by folding and cutting paper. What is it called when you just fold paper? Origami. Very good. A student sells small and large greeting cards decorated with kirigami at a craft fair. The small cards cost $3 per card, and the large cards cost $5 per card. The student collects $95 for selling a total of 25 cards. How many of each type of card did the student sell? I'm going to give you a major hint on this problem. When you're given a problem like this, where you are given a total amount of money and a total amount of objects, those two totals will be numbers that go to two separate equations. You'll have a total money equation and a total card equation. Use that to help yourself. Okay? Does there have to be an X or a Y in this? Not necessarily. Could I use A and B, L and G, large and or L and S, large and small? I don't care what variables you use on this because we're not putting this as a XY pair, because we're looking at number of small cards and number of large cards. Okay. Talk to your partner, come up with equations, and start solving. It's interesting that you all wrote the exact same equations, same variables in the same placement and everything. From the equations that we have up here, excuse me, gentlemen, from the examples that we have up here, what is X in reference to? X equals the amount of elephants. X equals what, please? Jack?
Small cards.
Small cards, so the size of them, how much they cost, how many. So what you will want to tell yourself is X equals the number of small cards. Give yourself that piece of information. Thus, Y is going to be in reference to what, please? Y is, Spencer?
The number of large cards.
The number of large cards. And that way, when we are looking at things, if I look at your problem, I can tell what's going on. If I look at your problem on a test or quiz, I can see what you're referencing. Then when you get your answer, you should have, small cards and large cards as your labels on your answer. Any questions in regards to the equations? Okay, please solve them. All right, ladies and gentlemen, as we look at this, Grant solved for Y, so that we have Y equals 25 minus X, and substituting it in, finding out then that there are 15 small cards and 10 large cards with the substitution that's up there. Now, I'm going to go to another screen. I'm going to show you that you can do it with the other way that some of you were trying to do it. Oh. How hard do you guys want to work?
Not very.
Not very. I know you pretty well. Yeah, you don't want to work very hard. Are there any questions on this one right now? Okay, I'm going to put up a new screen up here then. I have X plus Y equals 25, and what was the other equation? Plus 5Y equals 95. Okay, some of you are trying to solve for X or Y in this equation. Okay, 5Y equals 95 minus 3X, Y equals 95 divided by 5, Evan? 19 minus 3/5 X. Okay, I just introduced my first fraction. Lovely. So that means that I have to substitute this in for Y in this other equation. So that means I got X plus 19 minus 3/5 X equals 25.
That sounds like a lot of fun.
Oh, it's terrible. What's 1x minus 3/5 x? 2/5 x. And then plus the 19 equals 25. So now I've got to get the 19 to the other side. That becomes 6. So I got 2/5 x equals 6. And what do I have to do? I got to multiply everything by 5 halves, which is going to be 30 divided by 2, which is 15. Okay. Yuck. And then I still got to put that back in for one of my x's. Well, technically, usually I put it in right here. Yuck. Or I could put it in up here, a little better, and I'll come out with my same answer. Look back at what Grant did up here. Isn't it nicer to work with integers?
Yeah.
Yeah. So, could it be done with the fractions? Yes, it can, but I know how some of you are with fractions. God help you, right? So, you can do it with the fractions, but I would highly encourage that you solve for one of the variables that has a 1 or a negative 1 in front of it when you are working with substitution. I think Jake had asked me earlier, what happens if I have an equation that none of the variables have a 1 as a leading coefficient? Then it's up for grabs. You get to solve for whichever one, and it's possible to work through it. You just have to be really careful with your fractions. All right? Any questions at this present time? We're done.